Hi everyone, this is Chemistry Time 2 Week 9 quiz. Let's just get started. An aqueous solution of hydrochloric acid is added to lumps of calcium carbonate. Which of the following is an expected observation? Obviously, formation of bubbles. You should know this by now because we did it many times before that when an acid is added to a carbonate, it produces carbon dioxide which forms bubbles. And its net ionic equation is H2O plus CO2. Moving on. I was going fast in that question because we did it many times before. Okay. A polymer is a substance made up of macromolecules. It is formed when molecules called monomers join. These monomers are small subunits. Polymerization is a process of linking relatively small and simple molecules called monomers to form large macromolecular units called polymers. Polymerization occurs when molecules bond together by either breaking a double bond between their atoms or eliminating small molecules. Let me just show you in the notes how it is. So let's say here, where is it? Yeah. So let's say ethene. Ethene, as you can see here, had its double bond. So the double bond was broken, and it forms like this now. Okay. So that's what they mean in this question. So please go over the notes. It's very important. Moving on. This question was done many times. Isomers for it to be branch, okay, you have to when you're drawing it to check if it's an isomer. If you cross it one time with your pen, such as this, if you go one stroke with your pen, such as like you see one or like this, that's not an isomer. But here, let's say, oh, this is an isomer, and this is an isomer. Okay, so that's how to check if it's an isomer and if the branches are placed properly. Okay, propanoic acid C2H5COOH reacts with ethanol C2H5OH according to the below equation. Choose the name of the forward reaction. Always. When an acid reacts with an alcohol, it's an esterification. Okay, you have to memorize. Choose the name of the reverse reaction. Obviously, since I have water forming in the products, if I reverse it, so I'm gonna reverse it using hydrolysis. Okay. Part C, give the name of the product name. Always, when I have esterification, this is the I do alkyl alkanoate. So the alkyl is this. I just give I give the alcohol alkyl, so like ethyl, and then the acid O8. So I just put the acid's name and then I just gave it O8 at the end. So it's alkyl alkanoate. Okay. Okay, now label the structure of product A. Okay, so as you can see here, hydrogen was formed, right? How does hydrogen form? Hydrogen is two hydrogen atoms bonded with one oxygen atom. Yes. So this hydrogen atom here will bond with this OH, forming water, and this oxygen will bond with this carbon. Okay. So now, as you can see here, the hydrogen and the OH are no longer there, and the oxygen bonds to the carbon, as I told you. This oxygen bonds to this carbon. Compound B has the same molecular formula of compound A. Choose the name of the carboxylic acid and the alcohol that react together to form compound B. So as you can see here, I have ethanol propanoic acid. I can do ethanoic acid propanoate. Propanol, sorry. So propanol ethanoic acid, which is C. Moving on, question number 5. This is very important to memorize. It's in the notes. So please, you basically have to memorize this entire page. Choose the property used to separate petroleum into fractions, boiling point. Choose the most volatile fraction. Okay, so as you go down, the things are less volatile. Okay, and as you go down, boiling points, as you go down. No wait. So yeah, as you go down, so here is the most volatile. So as you go down, volatile substances, the substances are less volatile, and as you go down, boiling points increase. Okay. Moving on to part C. Drag and drop the following to arrange fractions in decreasing order of boiling points. Okay. So as I said, uh, that as you go down, it boiling point increase. So boiling point, so boiling point of C greater than boiling point of B greater than boiling point of A. So that's in decreasing order. Okay. Choose the identify. Okay, this really you have to memorize. I can't really say anything else. You just have to memorize this entire page, page 25. Very, very important to memorize. Please make sure to go over the notes. A polymer is formed when double bonds in the monomers break, allowing them to join together. This is called addition polymerization. A polymer is formed when monomers join at their functional group, eliminating small molecules. This is condensation polymerization. So this just memorize. You just have to memorize these statements, and we're gonna apply addition polymerization in the following question, I believe. Yes. So as you can see here, tetrafluoroethene of the following structural formula undergoes polymerization, forming the polymer Teflon. Okay, so as you can see here, I have a double bond. Okay, it's similar to the one I showed you earlier. Similar to, where did it go? Am I going the right direction? I don't think so. Okay, wait. Yes, here. So it's pretty similar to this. Okay. So this is called addition polymerization because we have a double bond. Remember, I just told you that addition polymerization is when double bonds break. Okay. Give the chemical name. All you have to do is you just add poly before the name. So polytetrafluoroethene. It's a big name. And as I told you, you break the double bond and then you make it two bonds with with these brackets, and n means the number of times it will repeat. Again, we did this question before. I'm going to go through it quickly. Two separate samples of ethanol C2H5OH are warmed in an acidified solution of potassium permanganate KMnO4 and in an acidified solution of potassium dichromate K2Cr2O7 respectively. The two reactions form the same product and can be represented by the following reaction: C2H5OH oxidized, producing product X plus H2O. As soon as you see this, this thing, oh my god! As soon as you see that one, it means it's oxidized. Okay, oxidized. Give the chemical formula. You just honestly you have to memorize it. It's somewhere in the notes. When adding acidified solution of potassium permanganate to ethanol, the color changes. As you know, potassium permanganate decolorizes, so it goes from purple into colorless solution. And potassium dichromate goes from orange into a green solution. You have to just memorize these stuff, and we did them many times before. I expect a similar question to be in the exam tomorrow. Moving on to question number 9. For going back to electrochemistry, Anna, I solve it in my own way. So I'm gonna take a screenshot actually of this question, and I'll show you my method. Perhaps maybe it'll be useful for you. So how I think of it is, I know it's gonna be Ca2 plus 2Fe minus, right? Okay. I look at the charge, this plus, this minus. Okay. For the plus, I put cathode. For the minus, anode. Okay. And for the cathode, I memorized it Rc. Anode, oxygen at the anode. So that means reduction happens at the cathode. Okay. Let me just make that see a little bit better. So that's what Rc means. And then oxidation happens at the anode. And that's what OA means. Okay? So let's just keep this. I told you cathode is the positive, anode is the negative, which is the anode, which is the negative charge. Okay, don't forget anode, positive electrode, cathode, negative electrode. Okay? Write the chemical equation for the half reaction at the negative electrode or at the positive electrode. Let's look at it now. How to move on now? How to move on? We know إنه الكالسيوم is at the cathode, right? Okay. I also had a special method. I think we all know about the oil rig, which is oxidation is loss of electrons, reduction is gain of electrons. So if it's gonna gain electrons, that means that the Ca2 plus, okay, is the one that's gonna gain the two electrons, forming the solid calcium, right? Okay, so that's how I think of it. So that's for part C. For part D, this is how I do it. I know that it's reduction. Right? Reduction. No, it's oxidation. Sorry. It's being oxidized. It's at the anode. Remember, oxidation at the anode. And the no oxidation is the loss of electrons. So I know that this 2Fe will lose 2 electrons, forming Fe2. By the way, you cannot write this, and I just do it so I can understand. So 2Fe, and then I'm going to take the 2E to the other side. It's going to be F2 plus a 2E minus. That's this. Do not, don't dare write this in an exam. Do not do this. This is just to show you, to show you like my way of thinking of in these types of questions. That I know that it's oxidation, so it's gonna lose the electron. So it's gonna minus, so, because we know loss is minus basically. So I take it to the other side. It's gonna be F2 plus 2E minus. Okay. Moving on to question number 10. Hydrogen fuel cells work like batteries, but they do not run down or need recharging. Choose the gases reacting in a hydrogen fuel cell. You should know this from before too. It's oxygen H2 producing H2O. A hydrocarbon is 75% carbon by mass. Okay, again, this question is repeated very much. Okay, so I have this carbon, which is CXHY. Let's say. Okay, that's a very nice looking H. Where's my eraser? Okay, so CXHY. Okay. How do I solve it? Okay. So it's 75% by carbon, so I'm gonna write 75 under carbon, 25 under hydrogen. Then I'm going to carbon has 12. Okay. Hydrogen has 1. It's more mass. Okay. So if I go to my calculator real quick, 75 divided by 12, you get 6.25. And 25 divided by 1 is 25. Which one of them is lower? 6.25. So I divide 25 by 6.25 and 6.25 by itself. So 25 divided by its answer. Oh, sorry. You get 4. So it's going to be a 1 to 4. I can say ratio, but I can't really. So X to Y. So it's going to be C1H4, which is basically CH4. Thank you so much for watching. I hope you have a good rest of your day and good luck tomorrow. If anyone has any question, please make sure to leave a comment, or if you have any just suggestion about my way of solving or anything, just make sure to leave a comment. Hope you have a good rest of your day. Goodbye.